Try to knock this out real quick. We were asked to find the end model behavior. No, wait, that's 35. 34, we were asked to find the vertical asymptotes. Now, vertical asymptotes occur when the bottom or the denominator equals 0. But here's the thing. So we want to know what values of cosine equals 0. So we're going to think of the unit circle. Remembering that any point on the unit circle is cosine comma sine. And this is 0, pi over 2, pi, these are the angle measures, 3 pi over 2. Okay? So what we're looking for is when x is 0. So this would be 0 comma 1 and 0 comma negative 1. So cosine of x equals 0 when x, or x cannot equal pi over 2, 3 pi over 2, and so on and so forth. But here's the thing. Cotangent is what? Cotangent is cosine of x over sine of x times 1 over cosine. Right? So the cosines cancel, and we really need to think about sine of x as well. Well, sine of x is going to occur at 0 right here, because we're looking at 1 comma 0 and negative 1 comma 0. So x cannot equal, God bless you, x cannot equal 0, it cannot equal pi, it cannot equal 2 pi, and so on and so forth. So these are our two different vertical asymptotes. So now if we go to graph this, what it would look like is cotangent. So I'm just going to graph it as cosine of x divided by sine of x, right? And then that will be times 1 over cosine of x. So I'd say times, and then I'm going to put this in parentheses, 1 divided by cosine of x. And so I've got this kind of funny looking pattern thing. It's really like 1 over sine of x, which is cosecant. But you're going to have an A vertical asymptote and a B vertical asymptote. And those are going to occur at these two values. That's the two places where you're going to have some issues. And I suppose you could generalize that. Does that make sense to you guys? Okay.
So how would you write the vertical asymptotes? Just like x equals.
Well, well, wait. Let me look at one more thing because I just want to double check one thing. I think it occurs at pi. Every integer of pi is where the vertical asymptote occurs. So, so let me trace this. I think if I hit this here, yeah. So it occurs at pi But now these are not vertical isotopes, these are just holes. So these are so we have two things going on. We have removable discontinuity, and then we have actual vertical isotopes. So where's that at? Yeah, it's right here. So right here, there's a hole in the graph, but the vertical isotope actually occurs at pi, any integer of pi. So let me, and I'm not sure. I mean, they're important to know for both. But this right here, these are holes. These are pluggable holes. And these are the vertical isotopes. And so you could just say K times pi, right? So the vertical isotopes occur at K times pi, where K is an integer, right? Now the solution manual actually separated that into A and B, because when you look at the graph, you know, depending on which, if you're approaching from this side, you go towards positive infinity, but if you're approaching from this side, it goes towards negative infinity. But at this vertical isotope, it flip-flops. This one approaches infinity, this one. So it separated it. It did 2K times pi, and then it did 2K plus 1 times pi, which would give you the even and odd integers times pi.
Okay. So I got it.
Okay?